Hello everyone, myself Revati Deshmukh from MSc first year, and today I am explaining about the Reimer Tiemann reaction in organic chemistry.
I introduce the scientists who discovered the reaction. First one is Carol Reimer and second one is Friedland Tiemann. They both give their efforts for the completion of this reaction. In next slide, there is the introduction given here for the Reimer Tiemann reaction. Now we see actually what happened in Reimer Tiemann reaction. The Reimer Tiemann reaction is a very important chemical property of phenol. Okay, so in this reaction, phenol reacts with chloroform in presence of sodium hydroxide at 60 degrees centigrade temperature, that is forming the orthohydroxybenzaldehyde as a major product. We can say it also a salicylaldehyde and parahydroxybenzaldehyde as a minor product. So we can say here the CHO group introduced on the ring because of the action of chloroform and NaOH here. Now, why we get salicylaldehyde as a major product here? Because the oxygen atom in CHO group and the hydrogen atom in OH group, in between them there is a intramolecular hydrogen bonding takes place. That's why we get the salicylaldehyde as a major product here. Now, let us see the mechanism of this reaction. The mechanism involves 3 steps. So in first step, we have to do the reaction between chloroform and NaOH here. For that, we have to dissociate NaOH firstly. As we all know, after the dissociation, it will give Na positive and OH negative ions. Now, this OH attracts the proton from chloroform. We can see the chloroform CHCl3 here. The shifting of bond between carbon and hydrogen towards carbon takes place so that why carbon get negative charge on it and hydrogen get positive charge. Now, the OH attracts the H positive ion and form water molecule, which is H2O. And trichloromethyl carbanium as an intermediate form here. Now, again for the satisfied the negative charge on carbon, we have to remove one Cl from trichloromethyl carbanium. So, how it will be removed? If we shift a bond between carbon and chlorine towards chlorine, then chlorine one Cl negative get coming out and we will get the CCl negative. CCl2 negative means dichlorocarbon is formed as an intermediate here. So we can see we get dichlorocarbon as an intermediate in first step. Now this dichlorocarbon is react with phenol in second step. In this step, from this phenol we have to remove the proton, means hydrogen atom. For the remove hydrogen atom, it takes place because for gaining more stability on ring. In the process of removing H atom from phenol, we react this phenol with NaOH, and then the OH negative ions again attracts the H positive ions from phenol, and H2O molecule will be get eliminated from here, and the O negative remains as it is here. Now the negative charge on O takes part in resonance and forms a double bond between oxygen and first carbon atom. Now here the carbon can only form the 4 bonds of hydrogen, as we know. That's why this first carbon atom shifted the bond towards second carbon atom, and that's why second carbon atom is get negatively charged. We can see here there is a negative charge present on the second carbon atom of benzene ring. After that, our intermediate means dichlorocarbon react as an intermediate in this reaction. Now this negatively charged carbon atom on benzene ring attracts the CCl2, means dichlorocarbon atom. And even on the second carbon atom of benzene ring, there is also one hydrogen atom is present. I will show there. Now the negatively charged dichlorocarbon attracts the positively charged hydrogen atom from CHCl2. And the bond between carbon and hydrogen shift towards the first carbon. And after that, it will be again shifted towards the oxygen atom. And that's why there will be the formation of double bond takes place between the first carbon and the oxygen atom. And this double bond again open up over the oxygen atom, and oxygen is also gaining their negative charge again and forming the compound like as the last product showing in this step. So overall this happens in second step of this mechanism. Now let's see what is the third step of this mechanism. The compound forming in the second step of mechanism, we have to react with it twice NaOH in the third step, and the 2Cl molecule from this compound get eliminated in the form of twice NaCl, and the two OH molecules from the twice NaOH get attached to the CH at the position of this 2Cl molecule. After that, as we all knows, two hydroxyl groups are not stable on one carbon atom, and they always prefer to eliminating in the form of water. So that's why, as I see here, from this both the OH group, there is a elimination of water takes place, minus H2O is given here, and the compound form like this after the elimination of water minus H2O, we can see here. Now after that, there is a important time takes place, means important step takes place here. There is the acidification takes place. After the acidification, means by addition of H positive ions, we get the compound salicyldehyde as a product. So here we get the salicyldehyde as a product, and the completion of mechanism takes place here. Now in next slide, I give some applications of the reaction. You can go through it. So here we get completed the overall mechanism of Reimer Tiemann reaction. So thank you so much.